Hey dude, it's Moni. Welcome back to the channel. Let's begin with the diagonalization using orthogonal transformation. Here only symmetric matrix can be diagonalized using orthogonal transformation. So the symmetric cases are classified as type 3 with a non-repeated eigenvalue and type 4 with a repeated eigenvalue. An important note, non-symmetric matrix that is type 1 and type 2 cannot be diagonalized using orthogonal transformation. So now let's see step-by-step procedure for diagonalization using orthogonal transformation. Let A be a matrix. First we write a given matrix A, 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. So here if you observe, the given matrix is symmetric. Symmetric is nothing but when the matrix is called symmetric if the given matrix is equal to its transpose, that is A equal to A transpose. Transpose means rows became columns and column became rows. So to find the eigenvalue, first we form a characteristic equation. So to find characteristic equation, and for a 3 by 3 matrix, the characteristic equation can be written as lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. Here S1 is sum of diagonal elements in matrix A. So diagonal elements are 2, 2, 2. So 2, 2, 2, 6. S2 is sum of principal minus, which means you leave first row and first column and write the remaining elements 2 minus 1, 1 minus 2. Then add, now you leave second row and second column and write the remaining elements 2, 1, 1, 2. Then you leave third row and third column and write the remaining elements 2, minus 1, minus 1, 2. Now you do the cross multiplication, 4 minus 1 plus 4 minus 1 plus 4 minus 1, 9. S3 is determinant of A. Next, to find S3, you take different columns with first row. You leave first row and first column and write the remaining elements. Then you multiply with first element of first row. You take first element of first row 2. Then you leave first row and first column and write the remaining elements 2 minus 1 minus 1 2. Then subtract, you take second element from the first row minus 1. Then you leave first row and second column and write the remaining elements minus 1 1 minus 1 2. Then you take third element from the first row, leave first row and third column and write the remaining elements minus 1 1 2 minus 1. Now you do the cross multiplication, 2 4 minus 1 plus 1 minus 2 plus 1 plus 1 minus 2 to get 4. So here an important note you need to remember, in S2 all signs are positive, but in S3 alternative signs are positive. So from this I can say, therefore the characteristic equation is lambda cube minus 6 lambda square plus 9 lambda minus 4 equal to 0. So on solving this equation, we obtained repeated eigenvalues. So to find eigenvalues, lambda cube minus 6 lambda square plus 9 lambda minus 4 equal to 0. So to find eigenvalue lambda, you substitute each value and check whether you get 0 on both sides. For example, you substitute lambda equal to 1 and check whether you get 0 on both sides. If not, then substitute minus 1, then 2, minus 2, then 3, minus 3. And here if lambda equal to 1 cube minus 6 1 square plus 9 1 minus 4 equal to 0. By solving you get 0 on both sides. Therefore, I can say lambda equal to 1 is a root. So we got our first eigenvalue. With this, we can find remaining lambda value by synthetic division. So synthetic division is nothing but you write the coefficient of lambda, then you multiply with eigenvalue. So the coefficient of lambda are 1, minus 6, 9, minus 4, then multiply with eigenvalue 1. Here you always start with 0, then you subtract, you get 1. Now you multiply this 1 with eigenvalue 1. Again you subtract, you get minus 5. Again you multiply this minus 5 with 1, you get minus 5. Again subtract, you get 4. Then multiply with 1, you get 4. At the end you get 0. So you have to get 0 at the end. If you didn't get 0 at the end, then the synthetic division which you did was wrong. So from this I can write lambda square minus 5 lambda plus 4 equal to 0. By factorizing this equation I get minus 1 minus 4. So by solving lambda minus 1 lambda minus 4 equal to 0, then lambda equal to 1 lambda equal to 0. So from this I can say hence the eigenvalues are 1, 1, 4. So the eigenvalue is repeated. So when it is symmetric matrix with a repeated eigenvalue, then it is follow type 4 from eigenvalues and eigenvectors. Next, to find eigenvectors, for eigenvalue 4 and 1, we find the corresponding eigenvector by solving a minus lambda I into x equal to 0. So I will show you a shortcut and easy way to find the eigenvector once the eigenvalue is known. You just subtract lambda from each diagonal element of A, then you multiply with x1, x2, x3, then equal to 0. Instead of solving all equations fully, we reduce the rows of A minus lambda I and directly find the proportional value of x1, x2, x3. This will save time in your exam. So as I said, you subtract lambda from only from the diagonal elements. So 2 minus lambda, 2 minus lambda. Other elements you write as it is, 1 minus 1. Then you multiply with x1, x2, x3 equate to 0. So let me name this equation as A. Case 1, if lambda equal to 4, then A becomes 2 minus 4 minus 1, 1, minus 1, 2 minus 4 minus 1, 1 minus 1, 2 minus 4 into x1, x2, x3, 0. By solving this, minus 2, minus 1, 1, minus 1, minus 2, minus 1, 1, minus 1, minus 2, x1, x2, x3. So now from this we write 3 equations. So you take first element from the first row, multiply with the x1, then second element from the first row, multiply with the x2, then third element from the first row, multiply with x3. So as I said, first element into x1, then second element with the x2, third element with the x3. Similarly, do for second row and third row. First element with the x1, second element with the x2, third element with the x3. Then first element with first x1, second element with x2, third element with x3. So let me name this equation as equation 1, 2, 3. Now by solving equation 1 and 2 using cross multiplication, rule. So x1 divided by Now you take coefficient of x2 and x3 from equation 1 and coefficient of x2 and coefficient of x3 from equation 2. So minus 1, 1, minus 2, minus 1, x2 divided by, you take coefficient of x3 and coefficient of x1 from equation 1 and coefficient of x3 and coefficient of x1 from equation 2. 1 minus 2 minus 1 minus 1. Then you take coefficient of x1 and coefficient of x2 from equation 1 and coefficient of x1 and coefficient of x2 from equation 2. Minus 2 minus 1 minus 1 minus 2. Now you do the cross multiplication. 1 plus 2 minus 1 minus 2, 4 minus 1. By solving this I get 3 x2 by minus 3 x3 by 3. Now I multiply this equation with 3. So I get x1 by 1, x2 by minus 1, x3 by 1. So from this I can say hence the corresponding eigenvector is x1 equal to 1 minus 1 1. Similarly do this with lambda equal to 1. Case 2, if lambda equal to 1 then A becomes two minus 1 minus 1 1 minus 1 2 minus 1 minus 1 1 minus 1 2 minus 1 x1 x2 x3 0. By solving this 1 minus 1 1 minus 1 1 minus 1 1 minus 1 1, then x1 x2 x3 0. So from this we have to write three equation. You take first element, then multiply with x1, then second element with x2, then third element with x3 equal to 0. Now second row, first element with x1, second element with x2, then third element with x3. Now third row, first element with x1, second element with x2, then third element with x3. So now I multiply negative in this equation. Now let me name this equation as 4 5 6. So here if you observe, all these equations are same. So I can write as put x3 equal to 0 in any of this equation. So let me take fourth equation. So 1x1 equal to 1x2. By bringing this 1 to left side and bringing this 1 to right side, x1 by 1, x2 by 1. So from this I can write hence the corresponding eigenvector x2 equal to 1 1 0. Case 3, if lambda equal to 2, then the third eigenvector be, let us assume that third eigenvector be ABC, then x1 transpose into x3 equal to 0. Here transpose means rows became columns and column became rows. Previously we got x1 equal to 1 minus 1 1 as in column. So here s1 transpose means 1 minus 1 1 in rows, then A B C. Now you multiply this first element with A, then second element with B and third element with C. Next, x2 transpose into x3 equal to 0. Previously we got x2 equal to 110 in column. Here x2 transpose means 110 in rows. Then multiply with a, b, c. First element with a, second element with b, third element with c equal to 0. So let me write these equations. A plus b plus 0c, 7th and 8th. So now by solving this equation 7 and 8 using cross multiplication rule, A divided by, you take coefficient of B and coefficient of C from equation 7 and 8. So minus 1, 1, 1, 0 equate to B. You take coefficient of C and coefficient of A from equation 7 and equation 8. 1, 1, 0, 1. Now you take coefficient of A and coefficient of B from equation 7 and equation 8. So 1 minus 1, 1, 1. Now you do the cross multiplication, 0 minus 1, then B 1 minus 0, C 1 plus 1. By solving I get minus 1, 1, C2. So from this I can say hence the corresponding eigenvectors x3 equal to minus 1, 1, 2. So till here it is same as we seen in type 4. From now you draw two table. So before that you need to know what is normalization. In orthogonal diagonalization we must use orthogonal eigenvector. So each eigenvector has to be normalized, then it is called normalized form. So normalized form is nothing but you take an element then divided by square root of each element is normalized form. So let me explain. You take an element then divided by square root of each element. So b square then c square. Now let us do with this eigenvalue. You take first element then root of 1 square minus 1 square 1 square, you get 1 by root 3, then minus 1 by root 3, then 1 by root 3. Same method you do for x2 and x3. You get 1 by root of 1 square plus 0 square, 1 by root 2, 1 by root 2, 0 by root 2. Then for x3, minus 1 by root of minus 1 square plus 1 square plus 2 square, I get minus 1 by root 6, 1 by root 6, 2 by root 6. So we got our normalized form. So we have a formula for diagonalization. D equal to n transpose into an. Here D means diagonalization. N means normalized form. A means matrix. N transpose means transpose of normalized form. So we know normalized form from this table. Then we know matrix A which was given in the question. So we already know normalized form. So it's easy to write transpose of normalized form. So from table I can write it as 1 by root 3 minus 1 by root 3 1 by root 3, 1 by root 2, 1 by root 2, 0 by root 2, minus 1 by root 6, 1 by root 6, 2 by root 6. So now it's easy to write n transpose. Transpose means rows became columns and column became rows. So 1 by root 3, 1 by root 3, 1 by root 3, 1 by root 2, 1 by root 2, 0 by root 2, minus 1 by root 6, 1 by root 6, 2 by root 6. So next to find an. A from A we already know 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. N 1 by root 3 1 by root 2 minus 1 by root 6 minus 1 by root 3 1 by root 2 1 by root 6 1 by root 3 0 by root 3 2 by root 6. You take first row of matrix A, then you multiply with the first column, second column, then third column of matrix N. Then you take second row of matrix A, multiply with the first column, second column, then third column of matrix N. Then you take third row of matrix A, then you multiply with the first column, second column, then third column of matrix N. First you take the first element of first row, multiply with the first element of first row in matrix N. Then you take second element with the second element, then third element with third element. Similarly, do for second row and third row. So 2 plus 1 plus 1 by root 3, 2 minus 1 plus 0 by root 2, minus 2 minus 1 plus 2 by root 6, then minus 1 minus 2 minus 1 by root 3, minus 1 plus 2 plus 0 by root 2, 1 plus 2 minus 2 by root 6, then 1 plus 1 plus 2 by root 3, 1 minus 1 plus 0 by root 2, minus 1 plus 4 by root 6. So now by solving this, an equal to 4 by root 3, 1 by root 2, minus 1 by root 6, minus 4 by root 3, 1 by root 2, 1 by root 6, 4 by root 3, 0, 2 by root 6. Next, d equal to nt into an. So 1 by root 3 minus 1 by root 3, 1 by root 3, 1 by root 2, 1 by root 2, 0 by root 2, minus 1 by root 6, 1 by root 6, 2 by root 6. Multiply with an 4 by root 3, 1 by root 2, minus 1 by root 6, then minus 4 by root 3, 1 by root 2, 1 by root 6, 4 by root 3, 0, 2 by root 6. So now you take first row of n transpose, multiply with first column, then second column, then third column of an. Then you take second row of n transpose, then multiply with the first column, second column, then third column of an. Then you take third row of n transpose, multiply with first column, second column and third column of an. So by solving this, I get 4 plus 4 by 3, 1 minus 1 plus 0 by 6, root 6, minus 1 plus 2 by root 18, 4 minus 4 plus 0 by root 6, then 1 plus 0 by 2, minus 1 plus 0 by root 12, then minus 4 plus 8 by 18, minus 1 plus 0 by root 12, 1 plus 4 by 6. Now by solving this, I get 4 0 0 0 1 0 0 0 1. So I can write it as D411. So these 411 are nothing but they are eigenvalues. If d value and eigenvalue which you got previously both are correct, then the diagonalization using orthogonal transformation which you did was correct. If not, then you leave the sum in exam and move to next sum. If you really understood my teaching, then like, share and subscribe to my channel. Thank you.